Welcome to this explainer. Look, we hear a lot of high-level buzz about AI agents these days, but today we're going under the hood. You're here because you want us to teach you the details, right? How exactly does a model move past just spitting out text and become a truly autonomous problem solver? What are the literal gears turning in the background? Well, we're going to break down the precise anatomical loop that makes all of this possible. Let's get right into it. Here's a quick look at our roadmap for today. We'll start with the AI agent workflow, then we'll meet Alfred the agent for a micro-level case study, explore the different types of AI thoughts, and finally wrap up with chain of thought versus React. All right, section 1, the AI agent workflow. Let's map out this core loop. At the very core of an AI agent's functionality is this continuous three-step cycle. It always begins with step 1, the thought. This is where the large language model acts as the brain, analyzing the prompt and figuring out the next logical move. Then, step 2, action. The agent doesn't just sit there and ponder, it acts. It reaches out and calls specific external tools, feeding them the exact structured data arguments they need to run. And finally, step 3 is observation. The agent takes whatever response it gets back from that tool and reflects on it. This thought-action-observation triad is literally the engine of agentic AI. Now, if you're into programming, you know exactly what this is. It operates just like a while loop. The agent doesn't run through these 3 steps once and call it a day. It cycles iteratively. Thought, action, observation, over and over again, based on the rules embedded in its system prompt. The loop only breaks when the agent confidently determines, okay, my ultimate objective here is completely fulfilled. Moving on to section 2, let's actually see this in practice. Let's meet Alfred the agent for a case study in those micro details. Imagine we ask Alfred, our weather agent, for the current weather in New York. This right here is Alfred's literal internal monologue during the thought phase. Notice how it doesn't immediately spit out a guess. Instead, it breaks the problem down. It identifies the goal, checks its available resources, and sets an immediate objective to call the API. It's planning before it ever acts. And this is where the magic happens for the action phase. Look at this granular detail. Alfred generates this exact JSON-formatted command. It explicitly names the tool, getWeather, and passes the precise parameter, location, New York. This isn't abstract, hand-wavy AI stuff. It's a highly structured data request designed to trigger a real external API securely and accurately. Boom! The API fires back. In the observation phase, Alfred receives this raw data from the environment. Partly cloudy, 15 degrees Celsius, 60% humidity. What's absolutely vital to grasp here is that this observation is injected directly back into Alfred's prompt as real-world feedback. It's the new variable in our while loop. So, armed with this fresh, real-time data, the loop cycles right back around to an updated thought. Alfred reflects on the observation and realizes, hey, I've got what I need. No further tool calls are necessary. The agent knows it has the info to finish the job. Finally, Alfred executes its last action. It takes that raw data, formats it into a nice, natural, conversational answer, and hands it back to the user. By doing this, Alfred successfully breaks out of the while loop. Objective fulfilled, task complete. It's honestly amazing to see that dynamic adaptation happen step by step. Okay, let's hit section 3, types of AI thoughts. We're going to peek even deeper inside that inner monologue. You see, an agent's inner monologue isn't just a monolithic, one-size-fits-all process. It takes so many different forms depending on the hurdle in front of it. It might be heavily focused on planning, like mapping out a sequence of steps. It could be analysis, trying to figure out a messy database error. Or prioritization, deciding a security flaw needs patching before anything else happens. It even does self-reflection. An agent can literally think, well, my last approach failed completely. I better try a different strategy. This internal diversity is exactly what makes these agents so incredibly versatile. And that brings us to our final section. Section 4, chain of thought versus React. Let's compare the overarching frameworks. First up is chain of thought, or COT. You've probably used this yourself. It's a prompting technique that guides a model to think through a problem step by step before answering, usually triggered by just typing, "Let's think step by step." But here is the critical detail. Chain of thought keeps all the logic strictly internal. It is a closed system. It's fantastic for complex math or logic puzzles, but it does absolutely zero interacting with external tools. Then we have React, which stands for reasoning plus acting. This is the exact framework our weather agent Alfred was using. It encourages the model to think step by step, but crucially, it interleaves actions, like using external tools, between those reasoning steps. React marries that internal reasoning with external actions and real-world observations. It's the absolute go-to for dynamic, multi-step tasks. Looking at them side by side really highlights the distinction. Both Chain of Thought and React utilize step-by-step logic. They both take time to reason. But Chain of Thought does not use external tools. React does. So while COT is perfect for internal, logic-heavy puzzles, React steps outside of its own brain to gather real-world info. As a fascinating final detail, the whole landscape is evolving fast. Recent models like DeepSeek R1 or OpenAI's Opai don't just rely on clever user prompts anymore. Actually, scratch that. It's not even just a trick of the prompt. They're fine-tuned at the training level to think via examples. They literally use structured tokens built directly into their architecture to explicitly separate the reasoning phase from the final answer. The thinking is becoming native to the models themselves. Well, we've covered a ton of ground today, digging into the exact granular details of how these agents think, act, and observe. Now that you truly understand the anatomical while loop making these systems autonomous, it kind of opens up a whole new world of possibilities, doesn't it? As these models evolve from simple text generators into complex, tool-wielding systems, what incredible real-world problems are you going to have them solve next? Thanks so much for joining me for this explainer, and keep exploring.